Hello everybody, welcome back. We're with the next part of the 10-minute series. We'll be starting with corrosion type 2, that is differential aeration corrosion. So this type of corrosion occurs when this is happening only to a single metal. Okay, in the previous one we had two metals. This is only with a single metal where some part of the metal is exposed to more oxygen and some part oxygen or air, and some part of the metal is exposed to less oxygen or air. Now generally what people think is that exposed to more oxygen, more air, so must be more reactive. So this acts as anode. Anode is when undergo oxidation. If it undergo corrosion, cathode will remain unaffected. This is a big blunder and it's a big no. It does not work like that. I'll tell you how. That what we did till now was wrong. Till here it is correct. Where this occurs in a single metal. What happens is that some part of the metal is exposed to more air, some part of the metal is exposed to less air. But the catch is that the part of the metal which is exposed to less air acts as the anode, and the part of the metal which is exposed to more air acts as the cathode. Okay, and now what you have to understand is that there's a key role. I told a key role last time also. The cathode remains unaffected. Okay, so anode is a which is going to undergo oxidation, and this will undergo corrosion. Okay, this is the basic concept. Less air acts as anode, it undergoes oxidation and undergoes corrosion. Which is exposed to more air that acts as cathode, it remains unaffected. Okay, generally we think opposite because of whatever reasons, but this is how it is. This occurs in metals exposed to different concentration of air or oxygen, right? Here more concentration of oxygen, here less concentration of oxygen. This is the main phenomenon. Now we'll be discussing two examples or two real life things on this. First one is water line corrosion. You can Google pictures also of an iron or whatever metal pillar, and this will be underwater, and this is above water, so more exposed to more air, this is exposed to less air, correct? This acts as anode, we know this acts as anode, this acts as cathode, this also we know. What happens is this undergoes corrosion, we know this undergoes corrosion, this will remain unaffected. What happens is that in the junction where the submerged metal and non-submerged metal, a water line gets formed. This water line is basically the corrosion or the rust line. So what happens is that even in this is basically that's the concept. Forms one line of rust in the junction of submerged non-submerged metal. It shows that below this line, whatever metal is that remains submerged. Correct. So part of the metal always submerged underwater that acts as the anode, basically. Correct. Even in ships, if you see in the pictures, they will also, this much part of the ship will be underwater, correct? So here one line of corrosion will come. Here one line of corrosion will come. Even in ships, even in water storage steel tanks, right? Big, they always have some amount of water stored in them. It cannot be left empty. So then you have water line coming in this junction. This basically is showing that there is less air exposure, more air exposure, corrosion happening. It's showing in this is one example. Okay, one more is pitting corrosion. This is another example of differential aeration corrosion only. Even this is differential aeration corrosion where there is difference in exposure of concentration of oxygen. In pitting corrosion, what happens, say this is a metal, or pipe, a large pipe. Over the years what happens, there becomes accumulation of dust. dust, dirt, whatever gets accumulated. Now what you have to observe is that this part becomes cathode, this part becomes cathode, this part becomes anode. It is less exposed to oxygen, less exposed to air, it is covered with dust, it undergoes oxidation, undergoes corrosion. Over the years, if this is not taken care of, right, left like that only, what happens? Pit formation, just by the corrosion, pit is formed. Okay, over the years, what happens? Oh, 1 second. What did I say? Because of dust formation, dust accumulation, this part, anode, undergoes oxidation, it will undergo corrosion. Correct? That will cause formation of pits. Over the years, if it is not taken care of, this thing deepens. It will cause literal holes in the pipes. You can search images of these, right? So dust goes on getting accumulated in that position, in that portion is exposed to less oxygen compared to the other parts. Correct? Here though oxygen is exposed well. Here oxygen is exposed well. Here oxygen is exposed well. Here oxygen is exposed well. So that's the cathode, that remains unaffected. Where it's going to get affected? Here. Where the dust is there less oxygen is going to be there, that is going to get affected, that acts as anode, that undergoes oxidation, then undergoes corrosion. The depth of the pit increases as the years pass by, like literal holes you can see in the large pipes. So in the next, that's all for today's video. In the next video we'll be seeing the third type of corrosion, that is stress corrosion. I hope you've understood the concepts till now. Feedbacks are welcome. See you on the next one. Bye.